bef- before we start this question, won't you think life is all about problem solving? In life, we solve problem like, let's say a problem is given in life. So what we do? We first check what that problem is, where that problem is, when that problem occur, how we are going to solve that, right? To solve how part, we again ask question, can we map that problem to a something previous experience so that we can handle it that way, right? So if you see any DSA problem, then it's the same way we are going to deal with that problem. Okay. So let's come to question now and solve this question. So what question says? Question name is course schedule, and it says there are total of num courses you have to take. Okay, and those courses are labeled from 0 to n minus 1, num courses minus 1. Okay, you are given an array of prerequisite where prerequisite of I is equal to a of I comma b of I. It means it indicates that you must take course bi first if you want to take course ai. Means here, let's say if a and b two courses are given, then it says like a comma B, it means you need to complete B course first, then only you'll able to take A course. Okay, so that is clear. Now the same thing is explained in below line. Okay, so now what we need to do? We need to return true if we can finish all the courses, otherwise return false. Okay, so let's see this example now. If we have two courses, A and B, and prerequisite are A and B, can we map that A and B to 0 and 1, right? Let's say we have courses 0 and 1. Okay. Now it says that 1 needs to be completed after 0 only, right? Means 0 needs to complete it first, then 1 will be going to complete, right? So can we do one thing like, can we map it to or draw some diagram for a while? And let's say we have course 0 and course 1. Okay. Now what they say? They say like you need to complete course 0 first, then course 1, right? That is prerequisite. 0 needs to be completed first, then 1. Okay. So can we draw something like this? Means 0 needs to be completed first, then only 1 can be completed. Now if you start from 0, so you'll be able to complete 0, then you'll go to 1 and you'll be able to complete 1. Now let's come to next question. Oh, sorry, next example. Okay. So what next example says? We have two courses and prerequisite are, let's say two courses means we are going to draw another graph or another diagram that is 0, 1. And here if you see what they mentioned, like 1 needs to be 0 to complete 1, you need to complete 0 first. To complete 0, you need to complete 1 first. Means to complete 1, you need to 0 and then complete 1, right? Means 0, then 1. And what the second option says, you need to complete 1 first, then 0. It means if you see in this diagram, if you want to complete 0, then you need to first do first course, right? And if you want to complete this first, you need to complete the other one first. There is a loop, right? Means whenever there is a circle or whenever there is a cycle, you won't be able to complete your course. In those cases, what we need to do? We need to return false, right? With this two example, we got that. What if there are other example? Like, can we draw some example from us? Let's say we have 0, 1, 2, 3, and 4 courses. Okay, and it is somehow like 0 needs to be completed, then 1 means first we need to complete 0, then we are going to get 1. Okay, what next? What if we draw like this? Means 1 needs to be completed first before 4, right? So the input will look like this. Means you will be having 1 comma 0. Before 1 you need to complete 0. What next? Before 4 you need to complete 1. So 4 comma 1, right? And let's say we have something like to complete 3 you need 2, and to complete 2 you need 0 and 4 both. Means the graph will be like this. To complete 2 you need 3. To complete 4 basically, right? To complete 4 you need 2, and one more, to complete 0 you need 2. right? Means 2 needs to be completed first, then 0. Let's say we have this input. Then how we are going to complete our course? How we are going to complete our course? If we start from here, from 4, can we complete 4 first? No, because to complete 4, you need to complete 1 first and 2 first. Means 1 and 2 needs to be completed before 4, right? If you come to 1, then can we complete 1 independently? No. It means before 1, you need to complete 0, right? Can we do 0 independently? No, it is dependent on 2. Means 2 needs to be completed first. Can we do or can we complete 2 first? No, because it is dependent on 3. So what will be the order? We are going to process 3 first, right? Post that will be processing second, right? What next? Now, can we process 4? No, we can't process 4 because still 1 is not processed, means 1 is not completed. So which one we can complete? Can we complete 1? No, we need to complete 0 only. Means third, we are going to process 0th node, 0th course. Next, we need to complete this one, that is 1. And at last, we are going to process 4th one. So this will be we are going to process. Now, what we understand from here? Are we able to derive some insight from here? Let's check. If you see, we started from 3 and there is no in degree here. Means there are no direction coming in toward node 3, right? That's why it's in degree is equal to 0. Let's analyze what are the in degree of each node, right? In degree of 2, id is equal to 2. Sorry, in degree of 2 is 1. In degree of 4 is id of 4 is 2, right? Means this one is 1 and this one is 2. Means we have two nodes. Sorry, two edges coming in, right? What is the in degree of node 1? If we see, node 1 has 1 only. So id is equal to 1. What is the in degree of node 0? In degree of node 0 is also 1. So which we are going to process first? That is third index, right? So if we start from the index, sorry, the element whose in degree is 0, then our algorithm might work, right? We are not sure what exact algorithm we are going to apply. But the thing is, we found starting point of our solution that if we start from here, we may land toward in means we may land to a situation where everything will align, means every course will be aligned, means there will be directed acyclic graph, means there is no cycle, means one way we can represent, right? If that is possible, then we can solve this problem, right? So if you see in degree is 0, if we are going to process 3 first, means 3 will be processed. Let's say 3 got processed. Okay, now what we can say, this one is processed, let's remove this edge, means we don't have to consider this anymore. If we don't consider this anymore, then won't you think that in degree of 2 will be decreased to 0, means one incoming edge is gone now, so in degree of 2 is 0 now. So can we repeat that thing? Let's try to process 2. When we are going to process 2, when the in degree of 2 is 0, and it is 0 in this current situation, so will be able to process 2. So if let's say we are successfully able to complete our course 2, then what will be the case? In that case, if you see, the in degree of node 0 will become 0 because you are already processed this node, and you'll be able to process this node, sorry, this two edges. So now dependency of this 2 edge dependency we can remove because 2 is already completed. If 2 is got completed, then in degree of 0 will be 0 and in degree of 4 will be 1. Now how the graph will look like? The graph will be similar to 0, 1 and 4, right? With in degree is equal to 0, in degree is equal to 1 and in degree is equal to 1. And the graph is like this. Now, can we process 0? Yes, because its in degree is 0, right? When we process this, this edge will be removed. because this got processed. What next? Now its in degree will be 0, right? So we just need to process this and this. So which one we are going to process first? We are going to process course 1 complete first, right? Then only we'll going to 4. So if we process 1, then this edge will be removed and its end degree will be 0. And finally we need to process 4, means we need to complete 4s. With this, we'll able to complete all the courses, right? So what was the order of processing? Means first we processed third, right? Third node. Next we processed second node. Next, which node we processed? Next, we processed 0, pose that 1, and pose that 4, right? We process in this way. Now, if you see, if we keep on drawing edges, then it will be like 3 pointing to 2, right? Now, 2 pointing to which? 2 pointing to 4 and 0. 2 pointing to 0 and 2 pointing to 4, right? 0 pointing to 1 and 1 pointing to 4. Isn't it a DAG, directed acyclic graph, right? If we can form this, and in that if you see there is no loop, right, means no cycle is formed. That's why it's possible to schedule courses in a such a way that we can complete all the courses, right? So we need to do this only, means we what we are going to do. First thing is like we need to calculate in degree of each node. What? Second, right? We need to process the element or the course whose in degree is 0. In our example, whose in degree is 0, that is third index, right? Sorry, third course. So second point is we need to keep track of all the in degree node whose all the nodes whose in degree is 0, right? 2 points. Now, third, what is the third point? If you are able to process that particular node, what you need to do? You need to get rid of the edges through which it is connected, right? Like if you see 3 is connected to 2, right? 3 is connected to 2, and if you are able to process 3 successfully, means you need to decrease the in degree of course 2 to 1 less. Means it was 1, it got reduced to 0. Means what was the third operation? If you process any node, then you need to remove that edge and decrease the in degree. Now, again, you'll check your list. Means you need to come to second point, that was check the list and whose in degree is 0, process that out. Second or third point, I don't remember exactly. But the thing is, you got the idea now how you can solve this problem. This is what we need to implement, right? Now you have algorithm in your mind. I'll keep the algorithm here. Means first is first find in degrees. Second, process 0. Process 0 in degree element or course, right? What third? Whenever you whenever process decrease the in degree, right? That's it. That is something which we need to do. So how we can do that? Now we can do it like we find in degree list. What are the in degrees of each node? That is 0, 1, 2, 3, 4. And here in this case, we started from 0, right? And till 4. And we mentioned in degrees, right? In degree of 3 is 0, 1. And here 1, 1. And 4 is 2. 3 is 0, 4 is 2. Rest are 1. That you need to do. Means you need to run a for loop and get what is the in degree. Now in degree is with you. What next? You need to push this element to some data structure, right? Hence you need to keep track of what element you are going to process. So let's say we have some data structure DS and we don't know what we want inside it. So what we know right now is if it's in degree 0, then we need to insert it here. That is 3 we need to insert, right? Now if 3 is there, which element we are going to process. If 3 is there and we are processing 3, we encountered 3 is connected to 2. 3 is connected to 2, right? And its in degree is 1. So let's say 3 is picked from here. We are processing it. Next, we need to insert 2. Let's say we inserted 2 because this is processed and it is 0. Now, while processing 2, what we need to do? Let's say we are processing 2. Then 2 is connected to 1, not 1. 2 is connected to 0 and 4. You can see example, right? 2 is connected to 0 and 4. 2 is connected to 0 and 4. So we need to insert which element we need to insert. It will become 0, it will become 1. So are we going to insert 4 in our this data structure? No, because still some courses need to be processed before that. So we can't process that course 4. So what we are going to do? We are going to insert this one here. And now we are going to process this, right? So this way we have to process it. Now, what will be the what data structure we can think of? Means we need to store just like this. We have list as well. We have queue. We have stack, right? So if you see anytime we are just storing the element whose in degree is 0, right? So let's say we have a case like 3 and 4 node are like here. 1 is here and 2 is here. And the codes are like this. And there is 0 as well, and 0 is dependent on this line. So if you see in this example, in degree of 3 and 4 is 0. So you can easily process that. So you'll be processing this first before going to other section, right? So process 3 first or process 4 first, doesn't matter. It means you can solve this problem with stack as well, queue as well, list as well. Now, what will be the problem with list? The problem with list is if you will use list, you are, let's say here, I'll show you. Here in this case, if you use list, then the thing is you are going to process 3 and then you are going to remove it. You don't need 3 again. If you see here, you are going to process 2, then you are going to remove it because you don't need it, right? So the easiest and the best way to use queue here, as I mentioned, stack as well. This problem can be solved with stack and DFS as well. Okay, you can try that. But for simplicity, what I'll do is I'll take queue structure. Okay, let's say if you want solution from me, just comment. I'll give you solution of solving it through DFS as well. Okay, right now for easy way to solve it, we are going to do it with BFS approach. Okay, hence we'll be keeping this values in a queue and keep on solving one node at a time, right? That we need to do. Now you have pseudocode as well. You have an example, you solved an example. Now it's just that you need to code that out. So how we are going to code that out? Okay, let me go to the editor and let's write the code. Okay, so what is the first thing we need? First thing we need is in degree, right? In degree, that's it. We need in degree list. And in degree list, what we can do? Let's assume in degree of each node is too high. Int max, you can consider, right? So how I'm going to consider int max here? I'm just taking a very big number so that means it is always higher, like in degree is too high. Or even if you'll like, mm, we can do 0 as well, I guess. Let's say in degree of each node is 0 for now, and we have n nodes. We'll keep on changing the in degree. We don't need to set max or something right now. Initially, there will be n courses. Until and unless they are not connected, the in degree will be 0. So that's why I can think of writing 0 here. That will work, I guess. Okay. So what is n? N is equal to length of what? Nums courses. Num courses is already n, right? Num courses is n. Now we have prerequisite list. We need to convert that prerequisite list to adjacency list for processing, right? So what we can do, adj list we want, and adjacency list will be of n nodes, right? So that is from, let's say we have empty means none element n times. Okay. Or we can do one thing. Yeah, let it be that. Means no element or no adjacent element right now. Now, for each p in prerequisite list, for each list means p will be list of two numbers, right? So can we mark p as edge? It can be edge, right? Now, for each edge, we need to map that edge to our graph. So in adjacency list of edge of 1 plus equal to what? Dot append. We need to append, right? What we need to append? Edge of 0 means, let's say for 1, to complete 1, you need 0. Sorry, to complete 0, you need to complete 0 first, then 1. So 0 is here and then 1 is here. You need to complete 0 first, then 1. What does it means? Means whatever the 0 is here is connected to 1, right? Means here, don't confuse it with index. Means while explaining, I was like, you might get confused with index. Don't confuse it with index. If you see, this value is 0. So adjacency list of 0 means at 0th index, what we are going to do? We are going to append 1. Means 0 is connected to 1. That is direction is from 0 to 1. Okay, not the other way, right? So that we are able to achieve. Now here one case will be like, if adjacency list of this, if not means that is none. If it is none, then what we can do? We need to insert a list, right? Adjacency list is equal to this particular value is none. It means we need to create one list there. And in that list, we need to append this, right? Yes, this is how we need to create adjacency list. What next? If we have adjacency list, we need to calculate in degree, right? What will be in degree? So if you see that this particular node is going to connect with this, means this is 0 and 0 will point to 1, this 1. It means the in degree of this particular node needs to be increased 1, right? So in degree of this needs to be increased by 1, right? That is what in degree calculation will be. Now we will be able to calculate in degree. What next? If do we need adjacency list later? Not sure right now, but I guess it will be required. But the thing is, now we have in degree, we have adjacency list. Hence we have our graph with us, we have in degree. Now we need to insert those element in queue whose in degree is 0. So for id in degree, right? Now we need to iterate it. So what we can do for node in range, for range n, what we need to do? If in degree of I is equal to 0, if that is 0, then we need to insert it in q dot append or push. I'm not sure right now. I'll use append. Okay. If required, I'll change that out. So what we are going to do, we need to append this to this node, and degree of node is 0, then we are going to append it in queue. Now, while while queue is not empty, we are going to process it. So how we are going to process it? We need to declare queue first, right? Queue, we declared queue here. Now to process each element in queue, what we are going to do? While queue is not empty, we need the left one, right? So uh, queue dot pop left and store it somewhere. So what it will pop? It will pop from which node we are actually processing it, right? So we'll be getting that node. Now, node in degree of that node minus equal to 1. We need to decrease it. Means it's already 0. So we don't need to decrease actually. We can remove this line. What next we need to do? If we have that node, then we need to get all the neighbors for neighbors. Each neighbor means for adjacent in adjacency list, adjacency list of that node, right? If in degree means we need to decrease now in degree, right? In, in degree of that adjacent will be decreased to 1. Now, if after decreasing it, the in degree of adjacent node is 0, then we are going to push it in queue. Queue dot append, I guess. If append will not work, we are going to use the push keyword. Okay, so this way, queue, this will be DQ. Means we use DQ like this, I guess. We'll see if there will be any syntax error. We'll see. Okay, so for each queue, for each node in queue, we are going to process it. So if we pop left one, so node will be here. So what are the adjacent node of it? We are going to decrease in degree of those. If in degree is equal to 0, we are going to push it in queue, right? With this, we are able to process all the nodes. Now, we need to just check for id in degree. If id is greater than 0, it means we are not able to process all the elements. So we can return false, else return true. So true will be in caps, false will be like this. I'm not sure about syntax right now. I'll just run, and if it gives some error, I'll fix it. Okay. Adjacency list of node. Node will this will be list actually, and adjacency list of node is a list. We need to do it for each of them. This is a list, and for each adjacent node, we are going to process it. Why? I don't know. Can I write it like this? Empty list for I range, and will that work? Yes. So right now there is some error, but okay. So what is the mistake right now? Let's see. We have n courses. In degree of each is 0 initially. We have adjacency list and adjacency list of size n of empty list. Okay. So we have 0 and 1 means two size, right? Two size, and for each, what we are going to check, we need to remove this. For each prerequisite, if edge 1, that is this 0, adjacency list of 0 dot append 1. Okay, we append 1 in 0. Now, in degree of this particular 0 needs to be processed first. Sorry, then we added one element here, means what we are doing. Just a second, right? I'll come here and see if 0 is pointing to 1. That is, 0 is pointing to 1. So, in degree, 0 is pointing to 1. So, in degree of 0 is 0. So, here, if you see, in degree of this 0 will be 0 and in degree of 1 will be 1. Okay, what next? In degree for each, let's print the in degree, right? This will let us know what's the wrong here. Okay, so if you see in degree is 1 1. Now the problem is here, means we are checking if the queue is empty, then this will not work. For id in degree, if id is greater than 0, then we need to return false. Why it's not get executed? In degree is 1 1. What if we print it again? It's 1 1 still. id in degree key value will be there, right? What is id? For each value in degree, right? Print id 1 1 will be printed. If id, oh, I forgot to write return keyword, and I was keep on checking what's the wrong. Okay, so in that situation we need to return false. Okay, now the case one is false. Why? Here print q, 1 is there, right? Means 0 is pointing to 1. So why we inserted 1? Because in degree of 1 is 0. That's why we inserted it. And for each adjacent element of 1, now this is 1. Now adjacent element of 1, adjacent element of 1 is 0. 0 is pointing to 1. So in degree of 0 is, in degree of 0 is 0. So why we pushed 1? Here if you see this is node 0, and we increased. Okay, we need to increase the in degree of this to 1. Got it. Okay, so this is how we need to do. Now here, while writing code, I made a couple of mistakes, but in real time, you need to do it like this way only. Means, let's say if you have no way to run it, then you just have to dry run it. Instead of printing it, you'll be like running it on your own, but in pen and paper and testing it whether it's working fine or not. With that, you need to do it, right? These means this is the way you need to solve any problem. So you need to think why you are doing that, what you are doing that. Okay. So what will be the time complexity of this particular algorithm, right? If you see, there are n courses, and let's say the prerequisite are just edges. Then n courses e edges, right? What you do? You processed each edge. Means you are taking time here. That is time equal to e, right? O of, let us big O of, right? Big O of edges till for this loop, right? Now, if you see, to create this, you take node, order of node, and here you are taking space for each, right? So if you see, space is equal to, first here you take big O and space. Here you took time of big O of node, and space is also big O of means n size list, and each list size will be on the basis of what are the edges. So in total edges element. So how many space you are going to take? Order of edges at the end, right? GDG edges. This much space you are going to take. Now time is here. This. Now if you see, order of n time you'll take, order of node time you'll take to check what is the in degree, right? What next? To process queue, let's say you are processing some element, then what are the adjacent element of that particular node? You are going to check that out. Means in total, if you see, let's say you are exploring this, then you are going to check this once, right? From here, you are going to check this. What next? From 2, you'll be checking 4 and 0, right? This two edges. What next? Then you'll be processing 0 and just checking this edge, right? This one. So one check. From 1, again one check. If you see, in total, the number of edges, what are the number of edges? That time we are going to take to run. Means this while loop will take order of edges. And again, order of node time will be required for this loop, right? So if you see, you can add all this, like order of node is time, means space will calculate later. Time just check. Order of node, O, order of edge. V plus E, node plus edges. Okay, again node, 2 times node, 2 times edges, 2 times node, 3 times node, 2 times edges. So if you see 2 and 3 are constant, so you can consider node and edge is means the sum of 2 is what? Your time complexity. So overall time complexity will be node plus edges. Okay. And what will be the space? Space complexity will be order of n plus edges. Space complexity will also be same, right? Because in total, if you see, for each edges, for each edge, you are going to consider one variable, one space, right? And anyways, you are considering n space for this. So this will be your time and space complexity. So that's it for this video. This video is, I guess, too long, but yeah, worth seeing it. Means even I was making mistake, but this is how we need to solve any problem. So that's it. Thank you for now. See you in next question.